The relationship between two variables p and t is known to be given by the equation p is equals to mt divided by b plus t. The following data points are given. So we have data points where we have the t and the p. In this video, I'm going to determine the constants m and b by curve fitting the equation to the data points. So we have that data and that equation there. But looking at this equation that we are having there, it's not similar to any of the equations that we have looked at. So what we can try to do is we can try to rewrite that equation. I can try to invert it so that it might be similar to one of the equations that are common that we have looked at before. So if I invert it there, on the left-hand side would have 1 over p, and then on the right-hand side would have b plus t divided by mt. So I can go on and divide throughout by this mt, and would have 1 over p is equals to b over m multiplied by 1 over t plus 1 over m. In this case, we see that the equation now is almost similar to the equation of a straight line, y is equals to mx plus c. By comparison, we see that the 1 over p is corresponding to the y there. The b over m is corresponding to the gradient of that line, the m. The 1 over t is corresponding to the independent variable, the x. The 1 over m is corresponding to the constant c there. So at this stage, what I'll now go on and do is I'll go into Excel and then enter these data points. So I'll now go on to Excel. So now in Excel, I've entered the values for t and the values of p. So what we now need to evaluate are the values of 1 divided by t. So I'll press here, so it's 1 divided by t. Then we'll also need the values of 1 divided by p. So for the values of 1 divided by t, this is equals to, then I say 1 divided by, our t is in column A2 there, so it's A2. Then I press the return key, then I can go on and copy it. So copy this one here, then paste here. So I go on and paste the values here. Then I'll go on and evaluate 1 divided by p. So it's 1. I put the equal sign, then 1. Then divided by the p there is in cell B2. So it's B2. Press the return key, then copy this, then paste here. So I now have my values of 1 over t and 1 over p. What you now need to go on and do is plot 1 over t versus 1 over p, where the 1 over t is on the x-axis and 1 over p is on the y-axis. So what you do is we highlight the values of the 1 over t and the 1 over p. So when we highlight the values, when we are drawing a scatter plot, the values which are on the column which is to the left are the values that will be plotted on the x-axis. So I'll go on and click on insert here. Then we look for the scatter plot here. So we have our scatter plot here now. So what you now need to do is insert the trend line. So go to trend line. I'll go to more trend line options. Then more trend line options is clicked here on linear, but we need the equation for that line. So I'll click on a display equation on chart. So I'll click here. So we have our equation is appearing now on the chart, and I'll also click to display the squared value. So what we are having now on the chart here is that the equation of the line that we are having is y is equals to 0.3655x plus the constant 0.1062. So that's the equation of the line, and we are seeing that the r squared there is closer to 1. It's indicating a good fit there. So we now go on and evaluate the constants b and m. So the equation that we obtained from Excel is y is equals to 0.3655x plus 0.1062. So as we said earlier, the 1 over m there is corresponding to our c, And from the curve fitting, what you obtain there is the C is this value here, 0.1062. So what we would have there is 1 over m is equals to 0.1062. And to obtain the m, we use this equation. We would have m is equals to 1 divided by 0.1062. And that will give us an m which is equals to 9.4162. So we have obtained our m. We can then use that m to obtain the value of the b. For the value of the b over m is equals to 0.3655. And to obtain our b, we multiply 0.3655 by the m. The m that we obtained is this one there, the 9.4162. So we would have the b is equals to 3.4416. I can go on and substitute these values of m and b into this equation so that we have our p is equals to 9.4162 multiplied by t divided by 3.4416 plus t. So we can use this equation to predict future values of p for any given value of t.